everyone. Today I will discuss application of differentiation involving maximum and minimum. Alright, so let's have a look at this question. The diagram on the right shows an open box with a square base of side x centimeter and a height of h centimeter. The box is made from a piece of cardboard with an area of 75 centimeters square. So 75 centimeters square is the area of the cardboard. Show that the volume of the box V cubic centimeter is given by V is equal to 1/4 75x minus x cubed. So first of all, the information that we understand from the question are area is 75. Area of the box is actually inclusive of area bottom of the box plus area of the four rectangle faces, right? So then we will focus to the base, which is square x square, and the rectangle is x times h. So we have 4 sides, isn't it? So we have 4, so we times 4. So we express the h in terms of the x. Okay, and then we will substitute into the volume formula because the volume was given by the base, which is square times the h. Then we will get the answer for the volume shown. Okay, then for B, find the value of the x such that the volume is maximum. Whenever we see maximum, we will differentiate. So we will differentiate dv dx, and we will let dv dx equal to 0, right? That is the basic skills that we learned before that. So dv dx is 1/4 times 75 minus 3x squared. So it's equal to 0. So that means 3x squared equal to 75. So hence we can solve the x. We have x which is positive 5. We will reject the negative because x here is the side, length of side. So then we will do another time of differentiation, d2v dx squared. So we get 1/4 negative 6x. So we will substitute x equal to 5 into the d2v dx squared, and we are getting negative value, which is negative 7.5. So it is a negative value, so less than 0 means negative. So we can conclude that the volume is actually maximum volume when the side of the square base side is 5 centimeter. Hence, in order to find the volume, we substitute the x, which is 5, into the volume formula, and this volume is actually equivalent to 62.5 cubic centimeter, and is in fact is the maximum volume when the cardboard with the area of 75 centimeter used. Alright, so now let's proceed to another application of differentiation to the question involving rate of change. The diagram on the right shows a plank AB of length 10 meter leaning on a wall of a building. The end A is y centimeter from the level of the ground, and the other end B is x centimeter from the foot of the wall C. Find the rate of change of NA and the plank if NB slides away from the foot of the wall at the rate of 3 meters per second. So firstly, we will label x to represent the length, okay, from C to B, and the height is y from C to A. So the rate of change of the B slide away So it's actually the changes of x with respect to time, which is 3 meters per second given in the question. So now we need to find the rate of change of y dy dt. So we need to find the relationship between the y and the x. So then we will use Pythagoras theorem. So y square is 100 minus x square. So y is square root 100 minus x square. So we will differentiate dy dx. We get 1 over 2 square root, and then we will just write the dy dx, and then we are getting answer which is negative, right? Because when we differentiate negative x square, we get negative 2x. So the dy dx is having the value of when x is equal to 8, right? So we substitute by using the information from the question. When x is 8 meter, we will get dy dx, which is negative 4 over 3, which is negative. So hence, in order to find the rate of change of y, we will take negative 4 over 3 times with the dx dt, which was given in the question, right? So actually, when we look at that, it's actually negative 4 over 3 times 3. So the answer is negative 4 meter per second, right? So it means that the y actually will decrease. Okay, the rate of change of NA of the plank is negative 4 meter per second. Alright, the next one is the rate of change of NB if the NA slides down at the rate of 2 meter per second when y is equal to 6 meter. Right, this is a bit challenging. Of change of the NB of the plank if NA slide down at the rate 2 meter per second. Slide down means it will be decreased. So dy dt will be negative 2 meter per second. So now we need to find the relationship between the x and y. We still can apply the x square plus y square equal to 10 square Pythagoras theorem, right? So now we're asking to find the rate of change of x. So we'll write the x dt equal to the x dy times dy dt. So again, the same concept, we need to relate the x and y. So we'll write x square plus y square equal to 100. So that means we will actually express the x in terms of y. So x square is 100 minus y square. So then we will actually square root the x to get 100 minus y square. And then we will actually differentiate dx dy. So we will get 1 over 2 square root 100 minus y, and then times with negative 2y. So when we can substitute the y into the dx dy, and we'll get the answer for the dx dy. So when y is 6 meter, dx dy will get the value, which is negative 6 over 100 minus 36 is 64. Negative 6 over 8, right? So it's negative 3 over 4, right? So then we will use a dx dy and also dy dt. So we will take the value of dx dy from the differentiation just now. So we will get negative 0.75. And we need to times with the dy dt, which is negative 2. So the answer is actually positive 1.5. So logically, it sounds logic because the x is increasing with the time, right? The rate is actually positive. The x obviously will increase when y decrease. So the answer is actually x increased by 1.5 meter per second. Alright, so that is actually how we solve the rate of change by using chain rule. So let's get started with another question, which will be the last question, question number 5. This is actually also another challenging question. The diagram on the right shows a helicopter at a height of 135 meters from the ground. The helicopter moves horizontally towards the boy at the rate of 17 meters per second horizontally. Find the rate of change of the distance between the helicopter and the boy. So that is actually the distance which is labeled as S. Okay, the distance that I highlighted in blue color is actually S. So when the horizontal distance between the helicopter and the boy, so I label as X, because that are the two variables they're going to change, right? Okay, but we are asking to find the rate of change of the distance between the helicopter and the boy when the X is 72 meters. So how to do this? First of all, let's write down the rate of change of X is negative 17 meters per second because the distance becomes less. Okay, the rate of change of distance between helicopter and the boy. So this is very important. So actually this is the one that I label as S. So it's ds dt, right? So ds dt is ds over dx times dx over dt. Alright, so now we are going to form the relationship between the s and x so that we can differentiate them, right? So let's write down the relationship between s and x by using Pythagoras theorem. Okay, whenever you see there is a right angle triangle, always use a Pythagoras theorem. So actually it's s squared equal to 135 squared plus x squared. So then the s is actually square root of 135 squared plus x squared. So we have to differentiate this. So every time when we want to do rate of change, we have to differentiate, and then we substitute the value into them. So ds dx is actually 1 over 2 square root 135 squared plus x squared. Then differentiate the x squared, we get 2x, right? Alright, so then we will substitute the x value into that because the question actually gave the distance of the helicopter and the boy horizontally is 72. That is actually showing that x is 72 meters, right? So we substitute x is 72 into the ds dx. So we get the value for ds dx, right? With the ds dx, which is actually we obtain by substitute the x, which is equal to 72 meters, right? So now we are getting the answer, which is 8 over 17, right? So we are getting 8 over 17. Then we can use it to substitute into the ds dt, right? So ds dt is actually ds dx, which is 8 over 17 multiplied by the negative 17 meters per second, which actually we obtain from the question, right? So then we just simplify, we'll get the answer for ds dt is actually we are getting negative, right? Negative 8 meters per second. Logically is correct because x is actually decreased when the helicopter near to the boy, right? So I think this is application of differentiation involving rate of change. So I will share with you more solving problem involving application of differentiation. Till then, I shall see you in my next video sharing. Bye bye and have a nice day.